What is up, YouTube? It is I, Chaos, and we are back with another really exciting project. This is the start of this project, episode 1. Here we go, let's do it. We are going to make the Draco, the bush plane, the one and only, the awesome, amazing, insane brainchild of Mike Patey, right? This plane is amazing. It is a standard Wilga 104 MA 2000. He has modified this plane extensively. He went as far as putting a PT6A-28 Pratt & Whitney turboprop motor on it, increased the fuel capacity to hold the enormous 120 gallons of Jet A1 fuel that it required to put that motor on it. He's increased the wing chord, both front and back. He's increased the wing tips just slightly when he put more fuel tanks on the wing tips with the really cool massive headlights. He's got Airbus lights on this thing. There are so many lights. He put lights everywhere. This thing can light up the night bush like daytime. He's got FLIR cameras, backup cameras. Just the suspension alone that he put on this thing was insane. They completely rebuilt the lower main suspension system as well as the rear suspension system. The landing gear is just amazing. Massive 35-inch Alaskan bush tires on the front, 18-inch there was his sand tire on the rear. It was overkill. It's like a monster truck of the aviation world, but a bush plane. Everyone loves it. It's an amazing plane. Everyone can agree. So, I can't build a full-size aircraft. I probably could, but it's expensive, and I don't have the place or the resources or the money to do it. What I can do is make an RC model. Now, I have some experience with 3D printing. I own a 3D printer. It is an FDM printer, a TAS Lulzbot 6, a TAS 6. It is currently under maintenance. We are upgrading it to a 32-bit processor board. But that's not the printer I'm talking about for this project. I'm in the process of saving up for a Peopoly Phenom. That's right, one of those big buggers. Can print something about yay big in one go, right? We're going to print full wing sections, 400mm long sections of wing, all in one go. I have some experience with printing wings. That's a wing there. That was 3D printed on my FDM printer in sections, and I've covered it in foil, so it looks cool. We're not going to do that because we're resin printing. We're going to be printing the skin and substructure and everything all in one go. Places for components, channels to run the linkages and push rods and pulleys and cables and everything and wires and places for the lights, you name it. It's all going to get designed into the model so that we print it in one go and assemble. It's going to be beautiful, it's going to be glorious, it's going to be awesome. And we're going to go through that process. But to start off, we need to know what we're doing. What are our design constraints? How big are we making this aircraft? What kind of components are we going to put in it? What are our weight limitations? What is going to be the RPM on the motor? Because this is very important. I want to, and this has probably been done before, but I'm pretty sure it's a first for 3D printing. I want to 3D print a working variable pitch prop and spinner assembly for the motor, as well as a planetary reduction system for this motor. This is a motor out of an RC helicopter. It also goes through a gear reduction system. They are very high torque, very high RPM motors. I'm pretty sure this will be big enough for what I want to do. Maybe. I might have to go bigger. We will see. I've got to do the math on it. Lots of cool stuff. I want to make this RC aircraft as faithful to Mike Patey's Draco as possible. I've sent him an email. I've sent him a message on Instagram. I've left a couple of comments on a couple of his videos to try and get his attention to say, hey, look, I am going to make a replica of your plane. Is that cool? Like, am I going to run into any issues? I know I can't use the Draco logo that's on the plane. You guys have a trademark on that, so we won't be touching any of the logos. I can put the tail number on the aircraft, and I think the model number. That's about it. Rest of the logos and stuff, I can't touch their trademark. But as for the aircraft itself, because it is a commercially produced aircraft, the Wilga, I don't think I'll run into any problems of replicating that model. But your specific airframe modifications, I don't know. I don't think it's going to be an issue. I hope it's not going to be an issue. You seem like a really cool dude. So Mike Patey, if you ever watch this, please, can I do this? Do I have your blessing? I hope so. I don't know. Maybe I'll print a spare and send you one to America, and you can have one for your kids to play around with until you get Draco X built. Let's get into it. Right. So here's the thing. We have certain limitations, right? Limitations being material cost, right? The size of the print bed, my print volume, what is the largest cross-sectional area I can create in one go. This is going to limit my design specifications. we also have constraints of material properties, right? What is the strength of resin? It is quite high. If you want to know more about the strength of resin, I highly recommend going and checking out CNC Kitchen on YouTube. He's done plenty of integrity and deformation tests, shear tests, load tests of all different kinds of resins, FDM plastics. Really great channel. Go check it out, and you will be pleasantly surprised at some of the characteristics that you can get out of resin printing. So we can't go too big. I want a decent sized aircraft. I mean, come on, like, who doesn't? This thing is supposed to be a STOL, so a decent sized STOL RC aircraft would be a lot of fun. I don't want to go too big. I have limited space to store stuff and workshop space to work on it, and we don't want to go overboard. So within 3 meters is a reasonable size. I have one 3 meter long wingspan aircraft. It is a glider. It's a bird of time. I don't get to use it much. It's mostly packed up and stored away. We've moved house recently, so I might get time to use my aircraft more often now, but I'm focusing on my YouTube channel, which I think is cool because I'm doing some cool stuff and you guys enjoy. Now, 3 meters is the limit for the wingspan, but that's too big, right? I'm not printing 3 meters of wing cross section. Also, the cross section of the wing, the chord, the length from the front of the wingtip to the back of the wingtip, we have a limit on that, and that is determined by the bed print size. So I have a print size of 267 centimeters by 267 millimeters by 155 millimeters. So that, not much, right? That gives me a cross area, corner to corner, of about 308 right to the corners. We can't fully utilize that if we've got something with a bit of thickness to it, so that comes back into about 208. So based on that limitation is how I scaled the size for this aircraft, how big I want it to go. So I went and found some pictures, lots and lots and lots of pictures, right? I even went as far as to watch all of Mike Patey's build videos on YouTube, and the whole way through I'm sitting there with my screenshot key taking photos of every part and component, and especially whenever he had pictures of CAD designs up on the screen, when they had the 3D scans done of the Draco and they had those scans, those were in orthographic view. Those are perfect because it allows me to look at things without being skewed by perspective, and I can work out dimensions based on those images. If you want to learn how to take dimensions from reference material, Adam Savage is tested. Go check out Adam Savage on YouTube. He does a lot of videos on pulling dimensions off of reference material. All the information's out there to get on how to do stuff like this. So getting all of these photos and then working out, right, I have a limitation of how big I want to make this wing. So not just the photos. The other thing I went and did is I went and looked up balsa plans and model kits online for this aircraft. There are loads of really great balsa plans available for the Wilga. So I've downloaded a few of them. I went through them and I looked at them. Now the problem with balsa plans is they are faithful dimensionally to the scale of the aircraft to a point. They divert in certain ways. Some of those ways are to do with the material properties of balsa and using wood and paper and stuff to build these balsa airplanes and for skinning them. The other are manufacturing constraints. How do you cut and shape and glue and stick together bits of balsa to create the aircraft, and the techniques used to do that, the techniques of creating balsa aircraft, determine how they are designed in these drawings and these these designs. There are slight alterations to all of these designs on those constraints. Now, I have a totally different manufacturing constraint set, so I can go as faithful as I possibly can to the real aircraft. So I can deviate away from the constraints that were placed on the designers of these balsa designs. These balsa designs are really good for getting certain rough estimates of size and scale, like to get the wingspan and such. But out of all the ones I downloaded, I found variations that were enough to tell me I can't use any of them. They aren't close enough to what I want to do. So that's it. They're all out. But they're great reference material to look at to inform me on how to step forward with the design, how to go about designing certain substructures and members and stuff like that. So I went and got photos. I went and got the official documentation from EASA, the European Aviation Safety Administration, about the Wilga, its wingspans, loading, wing surface areas, all of those measurements for the standard Wilga 2000 MA. And from those, I jumped into Inventor. I grabbed some pictures of the Draco. There was one particular shot, I'll show it here, of the top-down view that they got with a drone. That was incredibly helpful. It was a very straight-on top-down view of the aircraft. It's perfect. I used that to I put a limitation, I scaled the image to the wing chord that I wanted, the size of the wing chord that I wanted. And then, because I've scaled the aircraft to that cross-section wing, I could then measure the length of one side of the wing from the root to the center of the aircraft. It worked out that the aircraft that I'm going to design is going to be 1,100 millimeters from the center of the aircraft to just before the end of the wing chord, so just before it goes to the sweep of the wingtip. The wing chord length is going to be 1,100 millimeters. That gives me a wing span of 2,200 millimeters. That's 2.2 meters. That is perfect. And then from that dimension, I can then work out what is my scale to the real aircraft. And this will help me then use the dimensions for everything on the aircraft in the real world to then directly scale down to what I'm making. So a 2,200 millimeter wingspan versus a 11 meter wingspan in the real world is a ratio of 5:1, which means I can then go and say, right, those 35-inch bush tires, they're 7 inches. Convert that to metric. I now have the diameter of my tires. That 102-inch prop that you've got on it, divide that by 5, convert it to metric. I have my prop size, 20-inch prop. That is a big prop, okay? So, and on top of that, I want to make it a variable pitch prop. This is going to be amazing. Working out the size of the spinner, the cowling, the length of everything, how I'm going to fit the components that I'm going to be using, like servos, all of that sort of stuff. I now have a baseline to start designing this aircraft around. But before we get to that, I have to first model said components. All of the servos, the motors, the ESCs, everything. I have to get models of that so they're ready on hand for me to use when I get to designing the aircraft and creating the models for 3D printing. So that's what this episode's going to be about. Let's get into it. All right, let's get into this. So, same as last time. That seemed to work really well. Video up, and I'll just comment on it. First up is the servo. Servos are super easy. It's just a box with another box cut through it to make the tabs. You measure the total length of the tab, the height of the tab, height of the box, the width of the box. You extrude it to the width of the servo. You're good. Hope you got a cup of tea or something. We're going to be here for about 9 minutes. All right. You'll see the video like stop for a pause, even though this is sped up 20 times. There'll be like spots where nothing's happening. And no, it's not your video buffering. It's me when I was recording the footage, stopping to take measurements of the actual objects. And I'm being very meticulous, very careful to get very good measurements, because the better I am at getting these measurements now for these parts, the less headache I'll have down the road when I start using these parts. I start printing parts and then they don't want to fit because I didn't do the right thing here. So I take super good care of taking measurements and making sure I get very accurate, as close as possible, tolerances, and then thinking ahead of how this part is used, how it will fit. That's why we have this thing in engineering called critical measurements and critical tolerances. These are things that have to be spot on, otherwise the part or thing doesn't work the way it should. That's what those pauses are throughout the video. Making those little teeth was a guesstimate. Those aren't accurate, those aren't real. I didn't sit there and count the teeth on the top. I will at some stage try and find information for those servos on that tooth count, or I will get a microscope or these cool lenses. They're pretty cool, yeah. So I will use these camera lenses, these macro lenses, and try and get some accurate information on the part. Next up, you saw that before. I was going to try and use the shaft generator tool in Inventor. I haven't used it before, so I thought I'd give it a go. It didn't work. I couldn't figure it out. It's not so intuitive. I think Neil from TFI, he said in a couple of videos, it's not the most intuitive thing. It's not as good as some of the other generative tools that Inventor has. So I will play with that another day and see how it works really, so that I can use it in the future. But this was such a simple shaft. It's just got a groove for the split clip. Using Content Center as much as possible. Bearings, these are the wrong bearings. They looked wrong to me when I put these ones on. I wasn't sure on them, but it wasn't a big deal yet. I'll get to that when I get to that. Because Content Center is a little bit tricky it gives you the list of the names of the suppliers and the types of bearings they are, and then each one of those has a family. So here I'm going through the list of the families of the different bearings now to look at what the sizes that are available in that family of bearings, that supply of bearings, until I find the one that was the right diameter and the right height. They all sit on the 5mm shaft though, so there's a lot of different small bearings, and we are going to be looking at tiny bearings a lot when we start developing the variable pitch prop. The way I want to do that, it's going to be compact, it's going to be robust, and it's going to be simple, because those are the key things. It's only a 4-blade prop, but we're dealing with high RPMs, we're dealing with very high stress loads, so engineering those to work in scale and properly, and then still also taking the thrust loads from the blades when they're generating thrust or reverse thrust, which means, yeah, reverse thrust. So we not only have to contend with forces, torsional forces, centrifugal forces, torsional forces of the blades wanting to push backward and forth when they're generating thrust loads back and forth on the shaft. So many different interactions that we have to deal with, and we're going to have to use the right kinds of bearings, and we're going to have to talk about the right kind of bearings and do some research. This is just the outrunner case for the motor. There's some, like this centrifugal turbine at the top there that sucks air in through the stators, keeps the motor cool. This is a pretty powerful motor. For its small size, it's got some beef to it. This thing ran up a decent sized helicopter, not one of the small ones. It was a pretty decent one. So here I'm just fiddling around with the spacing of those centrifugal blades to get because there's a little worm screw, a grub screw in there that you have to be able to reach with the Allen wrench, and if the blade's curving over too far, it gets in the way. Adjusting the shape and size of those centrifugal blades so that you can get access to that worm screw, and then just putting it all together like that. Nice and simple, easy peasy, keeping things so basic, because I don't need all the information here. Just the bare minimum that I need for designing the aircraft, because that's the important part. I'm not going to be producing motors from this. Yeah, so there, the motor's done. I'll put the wires. I haven't done any of the stators, although all the stuff in the middle of the thing, the motors and the magnets and stuff, I haven't bothered with any of that. It's just the outside that's important to us. We've done, also you saw there, have I put that little turntable in the wrong place? I think I have. So this is now the ESC. This is just the case for the ESC. There are no mounting holes or brackets on the ESC that I can utilize to, so I'm going to have to make a place in the fuselage of the aircraft where it'll snugly fit, where I can strap it down nicely. But I need to utilize the airflow underneath and the airflow on the top somehow. I'll use the scale intakes that are on the real aircraft and actually utilize and duct the airflow from those intakes to go over the aluminium. I've got it over here somewhere. Where is it? On the top surface there's this aluminum heatsink, and on the underside there's these holes. So I will find ways to direct airflow from the outside of the aircraft over these and into that. Somehow we'll work it out. We'll get there. It'll be really interesting. It'll be lots of fun. I can't wait to get into it. But first off, we have to do the boring stuff, which is make all the components so that they're available for us to use. Just doing the cutouts here for the wires. It's pretty self-explanatory. Like, these are so simple, some of these shapes. I mean, they're this way because when they get designed by the manufacturer, by the suppliers of these parts for the hobby industry, they get made as cheaply as possible in most cases, and the designers just are doing it as quickly as possible to still be functional. So there's nothing fancy going on. Even like the veins in the centrifugal air district like blower on the motor, that you saw, like, there's almost a one-to-one representation that I did on here that's on there. Like, it's It's not designed to be turbo machinery, it's just designed to fling some air out and suck air through the core of the motor. Ooh, this is fun. So this is the gear that comes with the motor. So this is it here. There's a gear tooth thing on the front here. So it flares out at the bottom here and gets wider at the base. And I assume this is for where the grub screw is, to fasten it to the shaft. They need more meat for the thread there. So they widen it out at the base. But its actual diameter is quite small. But you can see that on the screen, what I've designed. And how that looks. Pretty damn close. Alright, so that's all the modeling, all the CAD done for these components. The motor, ESC, and at the moment I've only got these servos done. Now, I have other servos. I also have these ones. So if you want to know what servos these are, the large ones that I've got are the TGY 930s. And then I've got a next step down, and this is a TSS-10MG. So this one, I'm not sure if these are Metal Gear all the way through, but these smaller ones that I have, and I also have these D56MGs. These are really small servos, and you can see the size of this one. This is a Metal Gear servo. I use these for the discus launch gliders that I've got for lightweight aircraft. Pretty powerful. They're nice and small. They're lightweight. I'm not too sure where I'm going to find use for these because of the size of the aircraft. Most of the places where I would need a control, these won't produce enough force. So maybe I can use these for things, cosmetic things like opening up the doors for the cockpit and whatnot, that sort of stuff. Doesn't really serve a function, but it's pretty cool. You flick a switch and the doors pop open. These smaller ones I do think I will use. Now I've only got 4 of these servos. I might have to order some more, but I need 1 each for the ailerons, and then I need 1 for the flaps, and then I need 1 for the rudder, and then I need 1 for the elevator. And if you count, that is 5. Not the best. Now, I could probably get away with using 1 for both elevators and have it mirror the action, but I don't want to really split that action like that. I'm not a fan of that. It's putting 2 loads of force onto the same servo. The servo has to work twice as hard, and then you also have more complexity in the linkages. Having 2 separate servos for the the ailerons would be better. So I could probably get away with using one of these slightly smaller ones that I want to use for the variable pitch control for the flaps, and then have a unique mechanism so that when the flaps are fully extended, the forces being applied by the air going under them and pushing against them isn't transferred back to the servo, and the servo doesn't get overloaded. That can be done with some clever linkages, or I can design a very high-pitched worm gear rod with a screw on it, and it moves a little collet. Collet is attached to a linkage that moves the flaps. So that way the forces can't be translated directly back to the servo as much as if it was directly linked. So that covers the servos, motor, and the ESC. Components are pretty much done. The only things I don't have are things like batteries. The batteries I have are not suited for this task, so I'm going to have to look at getting some batteries. We'll look at that when we decide what the weight class of the aircraft is and what we're going to need to run this. The ESC that comes with it is capable of taking a 2S through to a 6S LiPo, so we can put a fair bit of power through this. It's an 85 amp ESC to run these came together. So this ESC is to run this motor. 85 amps. That's a pretty decent package. So with all that said, we need to discuss now what's happening in the next episode. What are we going to do next? Because now I've done all the components, I've worked out the scale of the aircraft, and I've got plenty of reference material. We're all set to go, right? Pretty much. There's very little for me to still have to calculate and work out. The only things I have to do are the prop RPM, based on the size of the prop, what kind of RPM, what kind of pitch, the screw ratio that I need for that prop, but it's a variable pitch prop, so it's going to lean more towards what RPM I need. Similar size props at certain pitch ratios are capable of their thrust. I just need to get some of that information, put together a table with some data, work out what RPMs I need on that prop and what RPMs I can put out of this, and then I can calculate the planetary gearbox that's needed, if needed, and all of that jazz. That's kind of boring stuff, so I'm going to do that off camera in my own time. So next episode, we're going to make some wings. That's going to do it for this episode. Thank you very much for watching. It's been a bit of a long one, but I think it's been really enjoyable. I've had a lot of fun editing this one. It's quite a lot of fun. I'm excited for this project. I love aviation. I love planes. and I hope you guys do too. Tell your friends about it. I need a bit of help actually in getting in touch with Mike Patey. When his videos come out, leave a comment saying, hey, this Chaos guy, he's making an RC plane of your Draco. Go check it out. You know, let's make a little bit of noise so I can get a hold of him and make sure that everything's okay with making a copy of his plane. Because I don't want to get halfway through this project and get an email saying cease and desist. I don't think that's going to happen, but I just want to be safe. I feel better about getting in touch with him and getting the go-ahead for this, just out of respect for the work this guy does. He's a man after my own heart when it comes to engineering. It's just a get it done sort of thing, and the way that he solves his problems, I feel a close relation to his method and the way that I work. So, yeah. Until next time, I've been Chaos. Thank you to my Patreon, and I'll see you guys later.